day everyone! In this video, we will discuss about limits of trigonometric functions. These are the theorems about the limits of trigonometric functions. The limit of sine x as x approaches c is equal to sine c. The limit of cosine x as x approaches c is equal to cosine c. The limit of tangent x as x approaches c is equal to tangent c. The limit of cotangent x as x approaches c is equal to cotangent c. The limit of secant x as x approaches c is equal to secant c. And the limit of cosecant x as x approaches c is equal to cosecant c. With this, let us try to evaluate some of the following limits. Limit of 2 sine x as x approaches pi over 2. Since this is a constant number multiplier, then it can be written as 2 times the limit of sine x as x approaches pi over 2. Using the theorem presented earlier, we simply need to substitute the angle here on the variable x. So we will have 2 times sine of pi over 2. Now, we will evaluate the value of sine pi over 2 and that is equal to 1. So finally, multiplying 2 and 1, we will have the final answer 2. Therefore, the limit of 2 sine x as x approaches pi over 2 is equal to 2. Another one, limit of secant squared x as x approaches pi. The limit of secant squared x as x approaches pi is equal to the limit of secant x as x approaches pi quantity squared. Applying the theorem earlier, we will be substituting pi on the variable x, giving us with secant pi quantity squared. Evaluating secant pi, it will be equal to -1. Squaring it, we will have the final answer 1. Therefore, the limit of secant squared x as x approaches pi is equal to 1. For our third example, limit of x squared plus cotangent 2x as x approaches pi over 6. The given can be expressed as limit of x squared as x approaches pi over 6 plus the limit of cotangent 2x as x approaches pi over 6. Remember to substitute pi over 6 to the variable x, giving us with pi over 6 quantity squared plus cotangent 2 times pi over 6. 2 times pi over 6 is equal to pi over 3, while pi over 6 quantity squared is equal to pi squared over 36. Evaluating cotangent pi over 3, its value is equal to square root of 3 over 3. Therefore, this is the limit of the given trigonometric function as x approaches pi over 6. Other trigonometric limit theorems. Number 1. The limit of sine x over x as x approaches 0 is equal to 1. The limit of x over sine x as x approaches 0 is also equal to 1. And the limit of 1 minus cosine x all over x as x approaches 0 is equal to 0. Let us apply these theorems in the following examples. Limit of sine 3x over x as x approaches 0. Since we have a constant number 3 here, to apply the previous presented theorem, we need to multiply both the numerator and the denominator by 3. So we will have limit of 3 sine 3x all over 3x as x approaches 0. Since this is a constant number, we can use it as our multiplier. So we will have 3 times the limit of sine 3x over 3x as x approaches 0. We can apply here now the theorem presented earlier, and this is equal to 1. So therefore, we will have 3 times 1, which is equal to 3. Therefore, the limit of sine 3x over x as x approaches 0 is equal to 3. Another example. Limit of 8x squared over tangent squared 4x as x approaches 0. The given can be expressed as limit of 8 times x squared over tangent squared 4x as x approaches 0. Next, since we have squared here and here, we can actually express this as x over tangent 4x quantity squared. Moreover, since we have 4 here and we want to have 4 at the numerator, we will multiply both the numerator and the denominator by 4. Then, and since tangent is at the denominator, we can actually express tangent in terms of cosine over sine. Then, we can express this as 1/2 times the limit of cosine 4x times 4x over sine 4x as x approaches 0 quantity squared. This is equal to 1. Therefore, we will have 1/2 times 1 squared, which is equal to 1/2. I hope that you have understood the lesson. For our next video, we will discuss about continuity of a function. Thank you so much for listening and see you on our next discussion.